This will be Geometry Lesson 8.3. Today we will be discussing, we'll be beginning our studying of area, and today we'll be discussing area of squares and rectangles. And I have these two formulas here for you. To find the area, well, the area is defined as the amount of surface covered by a figure. And we got to remember it's measured in units squared, and I'll show you why here in a second of why we calculate that. So if we have a square right here, to calculate the area of a square, we simply take the side and we can square it. Now the reason we can do that is if I look at a rectangle, to find a rectangle, now some of us have heard this differently. The area of a rectangle is simply length times width. Some of us have heard it as base times height, and either or it's the same thing, to where we take the length, we take it times the width, and that's it. Well, if we look at this one, a square, if we call this the length, then this is the same. It's also the length. It's the same measurement. So when we take L times L, or when we talk about it as a square, we would take it as S times S, and that's why we can look at a square as an area figure of side squared as opposed to length times width. You could also call the area of a square as length times width as well. It's the same thing as a rectangle, because we do have to remember that it is a rectangle. Right? So that's the area formulas that we will see. The formula for the area of a square is side squared, or length times width. Either one is fine with me. I don't care which one you use. I would prefer this one, and I'll show you why here in a while. So I would prefer, if you remember, area equals side squared of a square, and area equals length times width for a rectangle. So those are the two formulas that we have for today. Now, the reason I'll show you here in a minute of why we measure in units squared is when we actually start calculating these. All right, perimeter. Perimeter is defined as the distance or length around a figure. Now, this is the sum of the sides. So to calculate that, we take the sum of the sides, and we worked a little bit with that already. Okay. So let's go to number one. Number one has a rectangle. These are rectangles, and we want to find the area and the perimeter of this. So to calculate the area, we would simply go length times width. The length is 10 feet, and the width is 5 feet. Okay. Now this will be the last time I write my labels inside here, because when we write this, this would be 10 times 5, and I'm going to rewrite this a long way, times feet times feet. So when we calculate it, it's 10 times 5, which is simply 50, and I'm guessing most of you saw that right off the bat. But here's why we have a different label. Feet is a measurement of length. But when we have feet times feet, that gives us feet squared, just like x times x gives us x squared. So that's why in math and geometry we use the label of square feet, because it's two-dimensional. One dimension, two dimension. Feet times feet is feet squared. So our area is simply 50 square feet. Now when we go back to calculate our perimeter, we have to remember that this is 10, this is 10, and 5 and 5. So we go 10 plus 5, which is 15, 25, 30. Now if you notice that, really what you can do in a rectangle is just take 10 plus 15, 10 plus 5, which is 15, and double it, which would give you 30. Now that's a measure of length, so 30 feet. 30 feet. All right, now when we go to number 2, we have a rectangle that has dimensions of 8 feet by 7 feet. So if we want to calculate the area, now I'm not going to do the whole feet thing. I'm just going to go 8 times 7, length times width, which is 56. And when we go to label that as our answer, it's 56 square feet, because that's feet times feet. Right? Now when we go to find our area or our perimeter, this is 8, this is 7. That would be 8. 7 is 15. Now remember, we can simply double that, or we can add all the way around. 8 plus 7, 15, 23, 30. Or we simply go 8 plus 7, 15, double it, and you get 30 feet. Now, not all rectangles have the perimeter of 30 feet. All right. Number 3, here we go. Now we have a square. Okay, so this is a square. All the sides are equal, and we have one side which is 10. So you got to remember, if one side's 10, that side's 10 as well. So if we calculate the area of this, now remember the formula I want you to remember for a square is side squared, and we will see why. All right. So to calculate the area of that, we're going to take this square, go 10 squared, which remember that is 10 times 10, which is 100. So our area of this square is 100 centimeters squared. Okay. Now perimeter is 10, 10, 10, and 10, which is 40. So if you think of this, if you have a square, the simple way to find the perimeter of a square is just take this. We have 4 of those. We take 4 times 10 is 40. That only works for a square. Now remember, perimeter is just a unit of length, a measurement of length, so which is centimeters as opposed to area, which is units squared. All right, now we go to number 4. So this is a rectangle. To calculate the area of a rectangle, we need length times width. Now we have the length of 5. What we need is this width. We don't have it. Okay, this goes back to what we've been doing since chapter 4. So if you look at this rectangle right here, we cut the diagonal there. So again, what I'm going to do is this mess, which I always did last chapter. If we cut along a diagonal, we end up having a right triangle. Okay, so you should start thinking, what do we do with right triangles? Well, we always do the Pythagorean theorem. That is correct. So what we're going to do here is we're going to calculate the height here, or the width here, using the Pythagorean theorem. Right? So the way we can do that is I could put an x, a w there, whatever. I could go w squared plus 5 squared. Remember that diagonal is always the hypotenuse, the c, 13 squared. Right, so again, on this one we had w squared plus 25 equals 169. We would subtract 25. We'd go through the whole process of Pythagorean, which we've done 100 times if you've been doing your work. You get 144, and then you square root that, you square root that. And the width that we were looking for is 12. Okay, we couldn't do anything with this area or perimeter until we found that that was 12 meters. Okay, now we can go into our area calculation. Our area calculation is length, which is 5, times the width, which is 12. That brings me to this question. Does it matter which one's the length and which one's the width? Oh, 5 could be the length or the width. 12 could be the length or the width. The only thing we can't use is that 13. No, the only reason we had that was to calculate the width. Right? So we take 5 times 12, and that gives us an area of 60. So our area is 60 meters squared. And then perimeter, remember what we can do is we go 15, 5, 12, 5, and 12. Or we can go 5 plus 12 is 17, double it. You get a perimeter of 37 meters. Right? And now, when we do number 4, number 5, we do the same process right here, but we need the width again. Alright, so we need the width again. So again, here we're going to do a quick Pythagorean theorem formula. No problem, we got Pythagorean theorem down. We should have Pythagorean theorem down. So we go, remember this hypotenuse and the diagonal are one and the same. So that's your hypotenuse right there. So we go w squared plus 8 squared equals that 13.6 squared. Okay, so you can start doing the math on this. Get 13.6 squared, and then you're going to subtract that 8 squared over. And then you're going to square root that whole mess, and you get 10.998 or whatever. So we'll probably call that 11. So the width is 11. All right, so instead of w here, we have 11 now. All right, now we can go into our calculations of area. All right, so when you do our calculations of area, the area of a rectangle is length times width. 8 times 11. So the area is 88. Our answer is 88 what? Well, that would be 88 square feet. Right? So when we go into perimeter, here we go again. 8 plus 11 plus 8 plus 11. If you want to write them on there, go ahead. I like to just simply go 8 plus 11 is 19. Double it. So we get a perimeter of 38 feet. Right? So that's how we do area and perimeter. Again, perimeter wasn't too bad. But now we're going to extend this a little bit. So we're going to do the same process. We're looking for area and perimeter. Sorry. I'm going to go ahead and cover this up, so I have a little bit more room to write stuff. So we're going to go area. We want our area calculation. We want our perimeter calculation. Now notice, the only thing that we're given here is that diagonal, and that this is a square. Okay. So what's unknown to us are these side lengths. Well, remember, in algebra, if you didn't know something, you just kind of went, all right, let's call this x. And now in geometry, you know if this is x, all these sides are x. So we could go right around the horn and put an x on all of them. Now really what I only need, I'm going to only put it at 2 of them. So I'm going to go back and get rid of those. Alright. So same process here though. This is a Pythagorean theorem problem. Slightly different than what we've done, but we're going to set it up the same. So we're going to do Pythagorean theorem. Now remember, that's your hypotenuse. So when we set this up, it's x squared plus x squared equals the square root of 50. Don't forget, we got to square that guy too. We square rooted, I know, but because that's the length. But we got to square it too. Now the thing about this, that square root of 50, it's like 7.01, 7.1 probably, 7.09, something like that. If you wanted to go ahead and put that as 7.9 and then square it, you could, or 7.1 and then square it, you could. But I'm going to leave it as this because this works out nice. So if we look at this, this is 1x squared plus 1x squared. Well, 1x squared plus 1x squared, if you remember from algebra, is 2x squared. Right? And we've done this before. The square root of 50 squared, these two guys end up just canceling out. We're just simply left with 50. Right? Now we have two things we need to get rid of. We have a multiplication and we have a power. The easiest thing to get rid of first is that 2. So what I'm going to do is I'm going to divide by 2 here and cancel this 2 out. So I divide that side by 2. I got to do it over here as well. So what we still have left is that exponent. We have that x squared. 50 divided by 2 is 25. Now we can get rid of that square. Now we're right back to the finishing process of Pythagorean theorem where we got a square root to get rid of that. Square root of that. So we're left with x. Square root of 25 is 5. Okay? That's not our answer. What that found for us is that simply found that this side was 5 and this side was 5. Now we can go into our process of area. Remember, the area of a square is simply side squared. So all we have to do here is take 5 and square it, which is 25. So the area that I have is 25. Now remember, back to your label was inches squared. Right? And the perimeter would be 5, 5, 5, and 5, or 5 times 4 for a square, which would be 20 inches. Remember, that only works, that times 4 only works for a square. So there's our area, and there's our perimeter. Alright, so let's get into some compound figures. Okay, let's get into some, well, let's answer question 7 real quick. If two shapes have the same perimeter, then they have the same area, true or false? So if we look, do all shapes that have the same perimeter have the same area? That's a false. You know, you may have one that has the same perimeter and the same area, but that's a false. That's not always true. Alright, let's look at these compound shapes. We're going to do this all chapter long, where we'll do a simple shape. We'll just watch the area, what's the area, and then we'll look at compound shapes. All a compound shape is when we put two shapes together. You know, if you can think of your bedroom or rooms in your house or our classroom even, is made up of not just one big rectangle. It's made up of a rectangle, and then I got another little rectangle or square in the closet. Uh, you know, so that's what we look at with compound shapes. Now, if you notice this one, I have a rectangle up here, and we have a square down here. Right? So now the trick to this is making sure we can find all our measurements. Okay. So what I'm going to do is first the area of the rectangle. Okay. So the area of that rectangle is 8 by 5. So we're going to take 8 times 5, which that gives me an area of 40. Okay, so inside, now if you just want to write this inside, that actually makes a lot of sense to me to do that. This part right here has an area of 40 meters squared. Now this part right here is a square. So this is 6, and this is 6, and then this is 6, and then this part's 6. But we don't really need to write that part because it's on the inside. I don't care about it. So the area of that square is 6 squared, which is 36. So the area of this square is 36 meters squared. Now you start thinking here, how do we find the total area? Well, we just have to add the two parts together. So we're going to take 40 plus 36, so our total area would be 76 meters squared. Now here's where perimeter gets a little bit trickier. Now I'm going to get rid of my areas. I don't need those. Okay, so to find perimeter, we need to add up all these sides. Okay, well now if you notice, some of them, they're not written there. But if this side's 5, this side over here is 5. So sometimes if we're going to have to find a side, we're going to have to look to the opposite side. Okay. Now remember, we put this 6 in here, and this 6 didn't really tell me a lot. But what this 6 is going to do, it's going to help me find this part right here. Now if you look up, this whole part from here to here is 8. And this distance is 6. We'll start thinking, what does that leave you for here? Well, 8 minus 6 is 2. So this part right here is 2. Just that little guy right there. Alright? Now if we look around there, now we have everything. So what I like to do is I just like to make a mark on there. And then I start adding. 8 plus 5 is 13. Plus 6 is 19. Plus 6 is 25. Plus 6 is 31. Plus 2 is 33. Plus 5 is 38. So the perimeter is 38. Now you're saying, well, didn't you forget this guy? Well, do we need to count that? Is that part of the outside of the figure? No, that's inside, so we only need 38 meters. That's it. So we have area by adding. We have perimeter by adding all the sides up. And remember, if we need to find something over here, we may have to look to the opposite side of that shape. Let's go to number 9. We have another compound figure here. So first off, let's find the area. This is pretty easy right here. This is 7 by 8. Well, 8 by 7, so the area of that rectangle is 8 times 7, which is 56 meters squared. So in here we have 56 meters squared. Here, this is this little 3 by 4 guy, so this has an area of 12 meters squared. So then to find our area, we just have to add those two together. So 56 plus 12 is 68, so our total area is 68 meters squared. Okay. All right. Now, when we do this perimeter part, now notice we don't know anything up here, so we have some thinking to do here. All right. So we know the distance from here to here is 8. So let's translate that across the rectangle. Now, that's what we learned last chapter. That opposite sides of a rectangle are equal. So this is 8. We can do that same thing down here. If this is 3, this little guy up here is 3. Now here's our little guy that's going to give us some fits here. So we got to start thinking here. All right. So we know that the distance from here to here is 4. We also know that this whole distance from here to here is, if you look across, is 7. So we have to take 7 minus the 4. That's kind of the segment addition postulate that we did way back in chapter 1. 7 minus 4 is 3. So we got a little 3 right there as well. Right? So we need that little 3 right there to calculate our total perimeter. Now remember, we don't need this 4 right here. That's not part of the perimeter. That's not part of the outside. Now again, what I like to do is just make a mark so I know where I start and where I finish. So I go 8, 11, 14, 18, 21, 29, 36. So my perimeter is 36 meters. Okay. So again, we can calculate area by adding the areas, and then we have to do a little bit of thinking to find perimeter. I told you I was going to make perimeter a little bit harder this section, and there it is. All right, let's find the area of this guy and perimeter. So the area, this guy is 9 by 5, so I'm just going to put it right in there, 45 meters squared. This guy is 6 by 4, so this is 24 meters squared. And this guy is 12 by 4. 12 times 4 is 48 meters squared. So now your job is to add those two together. You get 69, and then you get 77, 117. So your area is 117 meters squared. Remember, we're still talking about two-dimensional area right there, so it's meters squared. Now perimeter. Perimeter actually on the test that we have over this is actually the most often missed thing because we forget parts. Now remember, this 6 doesn't matter to me inside here. I don't have to add this as perimeter. I don't have to add that 6 as perimeter. But we need that 6 to find some things here. So I'm going to put it here as well. So we have 9. Now I'm going to start up here. We have 9 plus 5. Now this part we're missing. Now we know that the distance from here to here is 6. We know that this whole distance is 9. So we take 9 minus 6, which is 3. So this part's 3. 4, I don't know this part, so let's go find it. From here to here is 6. We look across, this whole distance is 12. So we take 12 minus 6, that gives me 6 here. We know 4, we know 12. Okay, now here I don't know, but again, if we're trying to look for this side, we just look directly across. That's a rectangle. Then this side is 4, this is 4, and this is 5. Now, if you wanted to, you could go ahead and add that and get that whole side together if you really wanted to. But we can do that here in a little bit. All right, so let's go perimeter. 9, 14, 17, 21, 27, 31, 33, 43, 47, 51, 56, so my perimeter is 56 meters. Remember, perimeter is a distance. It's a measure of length, so it's just meters. All right. Let's go on to the next one real quick. Let's do this one real quick. So again, I'm going to go ahead and calculate my areas. 4 by 4, this is 16. Uh-oh, don't know that one. We'll come back to that here in a second. Don't know this one. We'll come back to that one here in a second. So let's go back up to this guy. The distance from here to here we know is 4. Right? Here's 2, here's 4, this whole side is 6. Remember, this part is 2 looking across here. So the area of this guy would be 2 by 6, which is 12 inches squared. Let's start thinking here. Right? So let's think a little bit that this whole distance from here to here is 4. If you look up, is 4. This part's 2, so that leaves me 2 here. Now if we look up from this guy, from here to here, that part's 2 as well, so 2 plus 2, that gives me 4 here. So we had some thinking to do on that guy. Okay, so the area of this guy would be 2 by 4, which is 8. Alright, so now we can add our areas. 12 plus 8 is 20, plus 16 is 36, so my area is 36 inches squared. Alright, so I'm going to get rid of those area calculations, and now we need perimeter all the way around the horn. So again, let's start up here. Let's see if we have everything. 2, 2, 4, 4, 2, 2, 4, 2, 8. Okay, so we found everything in the process of finding area, so we can start adding. 2 plus 2 is 4, 8, 12, 14, 16, 20, 28. Okay, so my perimeter is 28 inches. Right, so we can calculate area and perimeter of those compound figures. All right. Now we're going to do a little bit of work backwards, and there's a three-step process I want on this. Okay. So when we do this, let's set it up. The area of a rectangle is 63 inches squared. Now notice what I'm given. The area is 63 inches squared. And the length is 9 inches. What is the width? Okay. So the first thing I want you to do in these is I want you every time. Now again, the process is going to seem redundant today and pretty simple, but I want you to do this for a reason. When our formulas get more difficult, especially in the chapter 9, you're going to have to do it this way. 2, what I want you to do is I want you to substitute in everything that you know. We know the area is 63. I know the length is 9. What I'm missing is the width. Okay, so we write a very simple formula now that we can solve, and we can find that width. Okay, and that's step 3, is just solve it. Simplify and solve it. Now this is a very simple solve. We just have to divide by 9. Divide by 9. 63 divided by 9 is 7, so the width is 7. Now what's our label? This is the width. It's 7 inches. Okay, so that's your answer. Right? Number 13, same process. Step 1 is write the formula. We're talking about the area of a rectangle, so stop and write the formula for the area of a rectangle. Step 2 is substitute anything we know. We know the area is 99 inches squared. Now, the width is 3, so I don't know the length, but I know the width is 3. Now, this is the same solve. I know it seems pretty simple to write these formulas down, but I want you to do it so when it gets harder, we're ready. We divide by 3, divide by 3. That's Gandhi. So my length now, step 3 is just solve it. My length is 99 divided by 3, which is 33. So my length is 33 inches. Okay? Let's go to some of these with a square. Now this is why I wanted you to remember that other formula for a square. Step 1, the area of a square is, stop. Let's write the formula for the area of a square. Area is side squared. Okay. 2, what is the length of the side? Okay, that's what we're trying to figure out. Now step 2 is let's substitute in. The only thing we know is the area. The area is 64 inches squared. We don't know that side length. That's what we're trying to find. Well, this is a pretty simple solve. This is that last step of Pythagorean theorem every time. All we have to do is square root. So the side is 8. Okay. Now, I want your work just like that on these problems, because this is how you do it. And again, when it gets more difficult, it's going to be a lot harder. So number 1, the area of a square, let's jot it down, side squared, is 121. So I know the area is 121, so that goes for the area. And what we're trying to find is what is the length of the side. So all we have to do, and again, you might be able to tell that right off the bat, but go ahead and set it up and show the work. Square root. The square root of 121 is 11, so the side length of the square is 11 inches. Okay, so there's your answer. Right. Now here, Justin's room is diagrammed below. The Home Depot will install carpet for $3.50 per square foot. What will it cost Justin to install new carpet? All right, so $3.50 per square foot. So what we need to do is we need to calculate how many square feet we have. Right? Now again, he has his room and maybe a little side closet here, so let's do the area calculations here. So the area of this guy is 120 square feet. The area of this guy, we got to do a little bit of thinking. The whole length over here is 10. This part is 2, so that leaves me 8 for this. So it's 8 by 8. So this area of this square is going to be 64 square feet. So the total area of Justin's room is 120 plus 64, which is 184 square feet. Okay, but now Justin's room is diagrammed below. The Home Depot will install carpet for $3.50 per square foot. So what we have to do is we're going to take our area, which is 184, and multiply that by 3.5. So we're going to take that and take that times $3.50 per square foot, and that means we get a total cost of $644. Now what's your label? Dollars. Okay, so there you go. So it's going to cost Justin about $644 to carpet his room. Right. Now these are reviews, so let's run through these real quickly to find all the missing angles in here. So if this is 140, we have 140, explain, vertical angles. These two are going to be 40 degrees and 40 degrees because they're vertical angles, and these form a linear pair. So up top here, 50 and 50, 130 and 130. So that goes way back to chapter 3. Up here, now these are parallel, that's the catch here. We only need one. 63 vertical angles, 63 corresponding angles or alternate interior angles, and 63 corresponding or AEA. How many degrees are in a triangle? 180. Add those. That's 90. That's 100. Subtract it. This guy's 80 degrees. How many degrees in a quadrilateral? 360. Add those. 210. 210. 295. Subtract 295. And that's going to be 65, so this guy would be 65 degrees. So some quick review: 180 degrees in a triangle, 360 in a quadrilateral. So your homework, let's finish this bad boy right here. We're going to find the missing angle and the missing side here. So no problem, this is a review. 180 degrees in a triangle, 180 minus 90 is 90, 90 minus 37 gives me 53, so this is 53 degrees. And then here we have two sides of a right triangle. To find the third side, that's good old-fashioned Pythagorean theorem. That's your hypotenuse. So we go 18 squared plus 24 squared equals y squared. Throw that in your calculator. Get 900 equals y squared. Square root y is 30. Okay, so that side is 30. So you do the same process over here. Just remember on this one, this is your hypotenuse. So when you set it up, it would be y squared plus 10 squared equals 15 squared, and you'll probably get a decimal on that one. So your homework will be to do lesson 8.3, finish that up, and if you have any questions, make sure to come see me during seminar.